Welcome back to Topic 31 for Algebra 1, Exponential Growth and Decay Functions. So in Part 2, we're going to look specifically at exponential growth functions. And we're going to start by looking at some word problems. I know, your favorite. For number 1, a petri dish has 20 bacteria that are doubling each day. How many are expected to be present at the end of 5 days? So we're going to start off with cubes. C in cube stands for circle, so we're going to circle our numbers. B, alphabet. U stands for underline the question. B stands for box important words. So we have doubling. I would also say each day or how many. And then E and S are for evaluate and for solve. So, starting off, we know a petri dish has 20 bacteria that are doubling each day. So on day 0, without any time having been passed, we start with 20 bacteria. After the first day, how many bacteria will we have? Well, because we know that we are doubling each day, doubling means that we are multiplying by 2. So if we are doubling, what is 20 times 2? That gives us 40. If we are doubling that number, now this means that we are multiplying 40 by 2. It doesn't mean that we are adding 20 onto it, but we are doubling 40. So we're doubling our previous entry. If we double 40, we get 80. And the pattern will continue. So then we get 160, 320, 640, etc., etc. Now it might look really simple. Well, we already found how many bacteria are supposed to be there at the end of 5 days, 640. So in this problem, it's simple, yes. But what if I were to ask you how many bacteria are going to be there at the end of 70 days? Would you really want to make a table for that long? Thank you, next. No. So let's create a formula. We know that exponential functions can be modeled by y equals a times b to the x, where a is my y-intercept, or the value that I initially start with. So I initially start with 20 bacteria, so I'm going to plug that in here. B is my multiplier, so it's what I'm multiplying every single time. Because we're doubling, we're multiplying by 2. And x is the number of times. So here we know x is going to be our number of days. So in this example, we specifically want to know at the end of 5 days. So we're going to plug in 5 for x. Now, if you can't do this in your head, that's okay. We're going to transition over to Desmos. So we have 20 times 2 to the 5th power. Now, what I like to do here, notice how I use parentheses. That's really helpful, especially when you plug into either Desmos or if you're on your calculator, just so we make sure that we are using the exponent of 5 and that's being applied to the 2. With that base. We don't want it to apply to this entire quantity, but just the 2. And looky here, we get 640, which confirms our previous value that we identified. So because we're dealing with a word problem, we're going to write our answer in a complete sentence. So at the end of 5 days, there will be 640, there will be, goodness, bacteria. I guess you know why this is not for English class. Any other mistakes? Think we're good for now. Okay. Let's move on to our next problem. Here, so we have a Girl Scout troop. Yum, yum, yum. has 10 boxes of cookies at the start of season and would like to increase their stock by 25%. Woo, lofty. How many boxes of cookies do they expect to have at the end of 6 weeks? So here, what we're going to do is, again, start off with cubes. We're going to circle some numbers. We got 10 boxes of cookies, 6 weeks, 25%. Underline our question. How many boxes do they expect to have at the end of these weeks? And let's see, box important words. So they have boxes of cookies. They would like to increase their stock by 25% per week. So how many cookies will they have at the end of our 6 weeks? So here, our measurement of time is we're dealing with weeks. So if we have on week 0, we start with 10 boxes of cookies. So this here is going to be my y-intercept. Now, after the next week, they want to increase their stock by 25%. So we see this 25%. Let's just convert this to a decimal just for the heck of it to make our lives a little bit easier. Remember, converting to a decimal, we start with our decimal at the back of this number. Because this is a percent, it means it's out of 100. You can see this 100 rearranged right here. And there are 2 zeros here, so we're going to move it 2 spots to the left, everything you own in a box to the left. I'm no Beyonce. Okay, so some people think, so are we going to multiply by 0.25? Well, let's try. If we multiply 10 times 0.25, we get 2.5. Wait, but I thought they were supposed to be increasing their stock. This means that they're decreasing their stock. That doesn't make any sense. One would think. So we're not going to multiply it by just 0.25. Instead, what we're going to multiply each week is 1.25. Now this 0.25 represents their percent increase. And the 1 right here represents what you already have. So we have to take into account that we're already dealing with 10 boxes of cookies, and we want to add 25% of that on. So we want to take, 25% of 10, we found that that was 2.5, but we want to add that on to those 10 boxes of cookies. So if we multiply 10 by 1.25, what do we get? We get 12.5. That's more like it. So we will get 12.5. And we're going to keep our pattern going. So we're going to keep multiplying by 1.25 every single time. And we want to figure out how many boxes of cookies will we have at the end of 6 weeks. So our next one will get 15.625. Our next one will get 19.531. Now I'm starting to round to the nearest thousands here. Now instead of keep going and going and going and going, let's create our formula here. So we know we have y equals a times b to the x. And here, our y-intercept is our 10. We already identified that from before. And our b is our 1.25. And we're raising it to the x power. Now we specifically want 6. So we're going to plug in 6 for x. So we'll get y equals 10 times 1.25 to the 6th. So let's plug that in. So 10 times 1.25 raised to the 6th power. We get 38.14697266. So let's round to the nearest thousandth. And we end up getting 38.147. There's that 7. Now, can we have a portion of a box of cookies? No. So they should expect to have, they should expect to have 38 boxes of cookies. Yum, yum, yum. Now, another way to see this problem, we know right off the bat that we're dealing with growth because we have this word increase here. So, exponential growth actually has its own formula. Now, you can do this using the y equals a times b to the x, but I just want to share with you another way that it can be written. So if you like to use this way, you can. Y equals RA, still the same, times 1 plus r to the x. So here, this 1 plus r, this is your b, and your r is your rate. So for example, our rate in this problem was 25%, or 0.25 as a decimal, and we added 1 onto that. So this is where it comes from. This is where the problem is derived from. So again, we still have that a times b to the x, but here we're just substituting 1 plus r in for b because of it is specifically an exponential growth problem. And that is